Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to be talking about random digit tables. Now, this is a topic that is required for the AP exam, but is actually pretty dated. Nobody uses random digit tables anymore to find random numbers, but the AP exam might have a question on it. So we will be quizzing on this in preparation for the AP exam. Let's dive in. This is a random digit table. Sometimes it's called table B, sometimes it's called table D. It just depends on who is providing the table. You'll notice on the left-hand side, we have line indicators. So each of these numbers on the left, 101, 102, and so forth, is an identifier for the rows. Then each row consists of groups of 5 digits that were somehow randomly generated and given to us. So this is supposedly a list across from left to right of random digits. Whenever you're using a random digit table, you want to start from the first row unless you're told to do otherwise. You're going to move from left to right, grouping the digits as needed. If you get to the end of a row, you need to start down with the next row below it. Let's run through a couple of examples. Let's say you're planning a report on dorm living on a college campus. There are 4 dorms with 5 floors, each on the college campus. Explain how you could use cluster random sampling to obtain a sample of residents from the dorms. We looked at this problem previously using a random number generator. But here, since we're going to be using a random digit table, it's important that when we number all the floors from 1 to 20, that we actually we forced all the numbers to be 2 digits wide. So we're actually going to number them from 01 to 20. Now moving to the random digit table, since we're dealing with 2-digit numbers, again, we're going to start in the first row, and we're going to select 2 digits at a time, 19. 19 is between 1 and 20, so the 19th floor would be included in our sample. 22 is the next 2-digit number that is not within our data frame of 0, 1 to 20, so we would throw it out. 39 is the next one. Again, we would throw that one out. 50 is not in the data frame, throw it out. 34 is not in the data frame, and we're going to just keep moving 2 digits at a time. 5, 05, would be in the data frame, so we would include this floor in our data set. 75 is not. 62 is not. 87 is not. Oh, but 13, 13 is between 01 and 20, so that would be included in our sample. And we would continue this process. We would throw out 96, we would throw out 40. 91 is not in our data frame, so we would throw that out. 25, 31 are both over. 42 is over. 54 is over. Now we have a 4 here. That's going to be paired up with the 7 in the second row because we ran out of digits in the first row. That one gets thrown out. 36 and 76 are both too large. 47 is too large. Ooh, and then 15. We're going to stop here, but you could continue this process to get as many floors as you wanted to include in the sample, throwing out any numbers that are not within our data frame or are not between 01 and 20. Let's look at a second example. In a recent study, 166 adults from the St. Louis area were recruited and randomly assigned to receive one of 2 treatments for a sinus infection. Half of the subjects received an antibiotic, amoxicillin, and the other half received a placebo. Describe how the researchers could have assigned treatment to subjects if they wanted to use a completely randomized design. So here, we're not going to sample, we're going to assign treatments. Again, it's important for every subject or every item that we're selecting to have the same number of digits in it. So when we number the subjects from 1 to 166, we're actually going to number them 001 to 166 to guarantee there are 3 digits for each subject. Now back to our random digit table. Again, we're using 3-digit numbers, and so we're going to select the first 3 digits. 192, that is not within our data frame of 001 to 166, we throw it out. 239 is not within our data frame, so we'd throw it out. 503 is not in our data frame, so we'd throw it out. 405 is not in our data frame, so we would throw it out. 756, again, not in our data frame. 287, not in our data frame. 139, fantastic, that is in our data frame. So the first subject that would be picked for the treatment group of amoxicillin would be subject 139. Now you can see we're having to skip a lot of numbers. So this is not a very efficient method of going about this. So be very thankful that we have random number generators on our calculators that allow us to do this much more efficiently. From here, we would continue to look at 3-digit numbers, either including or excluding them based on if they fall within our data frame or not, until we got 83 subjects that would be included in the amoxicillin group. This would take us a very large amount of time. As you can see here, I still have not found a second one. Oh, here we go. 150 would be included in the amoxicillin group. And we would continue on with this process. I am not going to finish finding all 83 to save you from being extremely bored. I'll leave you with this quote by George Washington Carver. Thank you for joining us, and have a great day.